Hello, this is Ms. DB. In this video we are going to solve quadratic equations by factoring. So we're going to start with a review of the zero product property. This says that if the product of two quantities equals 0, at least one of the quantities equals 0. So for example, 3 times 0 equals 0, 0 times 4 equals 0, 0 times x equals 0. If one of the numbers equals 0, then the product equals 0. So we're going to use that in the following way. If you are asked to find the solutions or the roots of a quadratic, then we are going to set it equal to 0. Sometimes you're given f of x equals x squared plus 2x minus 15. So sometimes you're given it in function notation. Sometimes it'll look like equation y equals. But first step is to set it equal to 0 if it's not already. Then we are going to factor this part of this left side. And this one factors as x plus 5 times x minus 3. Then we're going to use the zero product property. That says that if we know the answer is 0, then either this is 0 or this is 0. So we pick both of them and put two separate little equations to write, and then we solve each equation. Like for this one, we would subtract 5 from both sides, and we get x is equal to negative 5. On this one, we would add 3 to both sides, and we get x equals 3. So there's two possible solutions. You need both of them for the answers. You can check by plugging them back into the original. They both should work. So in these first 5 problems, the quadratics have already been factored. So the first couple steps have already been done. Your step that is remaining is to set each of these equal to 0, use the zero product property, and see what the possible solutions are. So one of the equations would be x plus 1 equals 0, and the other one would be x minus 3 equals 0. And you solve each of these equations to find your two answers for x. So in the first one, I got x equals negative 1, and my second one, I got x equals 3. Both of those are answers, and you would write both of those as answers for number 1. If you get a problem like number 4 and 5 where there's a number in front of the x, that means it's going to be a two-step equation when you use the zero product property. Sometimes you'll get fractions for answers, and that's fine too. So in this one, you would add 4 to both sides to begin, but that's not the answer because we want t. So we would still have to then divide both sides by 2 and to get our answer of t equals 2. And don't forget to finish solving the other one, set this one equal to 0 to find the answer. So for each of these, you will get 2 answers for these problems. Here's the steps that you're going to do for the next batch of problems. First of all, you have to set this equal to 0. So these are going to be given in function notation. Yep, they're all in function notation. So your first step is to set that equal to 0. So take away the f of x and write that it's equal to 0. We usually put the equal 0 on the right side. That's not a rule. It's just a practice that we do, but you don't have to do it that way. You could put the 0 equals on this side if you prefer. Then you factor. So you factor x squared minus 3x minus 10. Make sure that you check by FOIL. Make sure you remember how to factor. We've already worked on that in this class. Then you set each of these equations to 0. So we have x minus 5 equals 0 or x plus 2 equals 0. Then you solve each of those equations. So these are the 4 steps you're going to do for each of these problems. Let's look at number 9. So our first step is to set the function equal to 0. So write the side with the x squared plus 3x minus 108 equal to 0. Then we are going to factor. This would factor as x, I don't know, something, something, something. And then the second set of parentheses will also be x. I'm not sure what the factors are going to be yet, so I'm just going to leave the space there. Now over here, I'm going to figure out what is negative 108. What are the factors of negative 108 so that when we add those factors together, we get a positive 3. 108. Well, 1 plus 8 is 9. If the sum of the digits of a number is divisible by 3, it will be divisible by 3. So I know 3 times 36 our factors. One of those would have to be negative in order to get a negative answer, but neither of those are the right answer because that does not leave me with a positive 3 when I add them. How about 108 divided by, I don't know, 12? Let's see if that works. 9 times 12, that's going to be very nice because negative 108 would equal negative 9 times positive 12, or maybe the one that I need is negative 108 is equal to positive 9 times negative 12. Let's look at our, whoops, that's supposed to be a negative. Let's look at our problem again. We need a positive 3. So which one of these two factors would equal a positive 3 when we add them? Negative 9 plus 12 or 9 plus negative 12? It would be this one. Because if you take negative 9 plus 12, you would get a positive 3. So now I'm ready to put in the rest of my parentheses. This would be a plus 12. Okay, now we're ready for C. Set each factor equal to 0. So that means x minus 9 equals 0, or plus 12 equals 0. And then we have to solve each of those equations for x. So for this one, I would add 9 to both sides. Add 9. And I would get an answer of x equals 9. And for the x plus 12 equals 0, I would need to subtract 12 from both sides. So I would get an answer of x equals negative 12. And those are my two solutions then. And you will do the same thing for these other problems. So the first step on this one is to set it equal to 0. Let me just show you what that would look like. I would subtract 9 from each side, and I would have 16x squared minus 9 equals 0. And then you go ahead and factor. So this one says try difference of 2 squares. This one, to set this one equal to 0 is easier because it's in function notation. You would just have to write equals 0 after it and drop the f of x. And this one's all. All right, then there's one last part of this worksheet, and it is if you know the zeros, you can work backwards to write a rule for the function. So if we know what the zeros are, let's go back to number 9. If we know that the zeros are 9 and negative 12, you can work backwards. And you can say, well, that means that I must have had one part must have been x minus 9, and one part must have been x plus 12, and I can put them back together like this, and then I can FOIL that to get to this step. That's what we're going to be doing on these last few problems. So once they give you the zeros, we are going to write the factored form. So the factored form is going to be the opposite signs of these. So if a 0 is 1, that means x minus 1 must have been one of the factors, because then when you set it equal to 0, you would get 1 as an answer. And the other one must have been minus 2, because then when you add 2 to both sides, you would get 2 for the answer. So now we're going to write that in one nice form, x minus 1 times x minus 2. I guess I should write that this is equal to f of x instead of 0 now. And now we're going to FOIL this together to get our standard form. So I would take x times x is x squared. Outer term would be minus 2x. Inner term would be minus 1x. And the last times last would be negative 1 times negative 2. That would be a plus 2. Then we're going to, I should say that this is what f of x is equal to again. Front this time, and then that means that our function once we add our like terms would be x squared minus 2x minus 1x is minus 3x, and then we have our plus 2. So if we were given that quadratic and asked to factor it, we would get these factors, and if we were asked to find the zeros, we would set those equal to 0 and we would get 1 and 2. So we're working backwards to find the original function. And you can check by graphing you can graph your answer and see if these indeed are the zeros, if this is where they cross the x-axis. So for 18, you'll do the same thing, and 19, you'll do the same thing. Note that in 18, one of them is negative, so the opposite would be x plus 2 for one of the factors. All right, let me know if you have any questions, and have a great day.